Okay, this is the second lesson here on quadratics. So just take a moment to have a go at these questions here from the starter. You should now be able to do those ones. Pause the video, have a go. So assuming you've done that, take the x out first. You're left with a normal quadratic. Don't forget to actually solve it. What do we have next? Multiplying through by x, but actually going further than that, multiplying through by x squared will make it much easier to deal with this quadratic here and to solve. This one here, bringing the denominator up, thinking of it in brackets, moving everything to one side, and the usual techniques. You might find these easier to do by making some substitutions, such as everywhere there is an x squared, using a y. So for example, if x squared is y, x to the power of 4 is y squared. The first question then would become y squared minus 13y plus 36 equals 0. You could factorize this and just be sure to undo your substitution at the end. The same here. This is a good test of your index rules. So x to the 2/3. Perhaps you may wish to think of this as x to the third squared. And by doing that, you have an x to the third, another x to the third. You'll be able to make a quadratic and solve this. And finally, another example with exponentials. So completing the square and sketching. So completing the square means taking a quadratic and putting it into a format such as this, or more generally, such as this. There may be a number in front. In fact, usually there is a number in front of this bracket here. Okay. The reason for this is we only want to really see x appear just the one time. It lets us do all kinds of things, such as making insights in proof or sketching graphs and so on. So we could use it for solving if we're in this sort of situation here, perhaps because it's written this way already, or we know that a quadratic won't factorize. Completing the square can be a good option. For sketching it, remember from GCSE that at minus a, okay, this y will be equal to b, as this part here, this bracket will be squared, and this will be 0, 0 squared. This is useful for sketching applications too. So as a recap, when we expand out brackets in this format, we have a pattern here. Okay, in fact, I will extend that to the negative sign as well. What do we notice? Well, we notice that 5 is half of 10, or minus 5 is half of minus 10. Idea to sort of go backwards. If we know when we expand out, when we have an x squared and an x is appearing multiple times here, even when we simplify, we can go backwards. And we can say that half of 12 will be 6. What will happen is, and you can always do a grid to multiply this one here. When you expand this one out, you'll get x squared plus 6x, another 6x, and a 36. And simplifying gives us x squared plus 12x plus 36. It's important to compare to what you actually have. X plus 6 squared, in fact, gives us this. So to correct it, we need to take away the number, because the number is 0. And at the moment, x plus 6 squared would be too large. Some further examples then. Half of this one here, minus 16. I often like to think of this as a bracket, and then straight away subtract the number part that will be created. Again, And usually it won't be a 0, there'll be a +7. So using the technique we did above, this is the recommended way to do it. Half would be x plus 3 squared. Straight away, subtract the 9 that will be created and leave any other number there on the outside to simplify with as a very last step. So these are the format in which questions are normally given to you. So notice that now they are not 1x squared, they are 2x squared, or minus 3x squared. Here's what we do. In the form of the completed square, you need to be able to recognize this, that this is a completed square format. Factorize the 2 from both x parts. Leaves you with x squared plus 6x plus 7. Now, it is important to note, I have not completed the square here, okay? This is not complete. This is just a factorization because I want to be left with x squared. If I'm left with just a normal x squared on its own, I can do what I did before. So, make space for yourself. Square brackets recommended. Then complete the square inside. So, x plus 3, because 3 is half of 6, squared. And immediately what I will do is I will subtract what 3 squared is. Now, when we clean up, we need to apply this over here and over here as well. So the 2 just sits in front of the bracket being squared. This here is 9, so minus 9. Multiplied by 2 is minus 18. Finally, you simplify with the 7. So 2 lots of x plus 3 squared minus 11. People are very good normally at getting this one correct and this one correct. To make sure you get the final number correct, please give yourself space when you are working out. If you put the square brackets in and follow it this way, you will get all of the marks in this very, very common exam question. Let's do one more. First step, I would write it so that the powers of x, the largest power is at the front. As so, remember the 5, positive 5 can just be written that way there. Okay, they want this in a slightly different format, but actually I'm going to do that at the end. So what I do first is I factorize such that I have an x squared all on its own. This is a more challenging question because if I factorize out a negative from a positive, that will actually need to be a negative. And you can just verify this yourself. Minus 2x times minus 3 is 6x. The 5 is kept over here. Remember, I have just factorized out to set up the question. I have not completed the square. Now we're going to complete the square. Square brackets to give us space to work. X minus 1 squared minus, we could just say minus 1 because 1 squared is 1. You take that away. Distribute, okay, this minus 3 over these two parts here. I'm going to go over here. So minus 3 by x minus 1 squared. This is minus 1 multiplied by minus 3 is a positive 3. So plus 3 plus 5. And I would leave my final answer. Well, I would leave it as this, but actually the question says in this form. Notice it wants the positive number at the front. So actually it should be 8 minus 3 x minus 1 squared. And we are finished. The key steps. Number 1 is to get x squared on its own. Number 2, give yourself space to work. Okay, and by that I mean use brackets. 3, distribute the number at the front to both parts. So this is really about expanding brackets. So expand carefully. And finally, you will just clean up the terms. Pause the video here and have a go at these. It will take you a bit longer at the start, but you want to practice these so that you are doing these within a couple of minutes each. So I'm assuming that you have done that. Solutions appearing on the board now. It should be said there are other ways to do these questions, but this is probably the easiest way to do it. And so on. So notice there we were dealing with expressions, quadratic expressions. There was no equal sign in either of these, but now there is. What we could do is, instead of completing the square directly, in a situation like this, we may be able to simplify it and deal with x squared straight away. The reason for that is, as long as you divide throughout by the same number in this expression, you should be okay. And the fact that there is a 0 on its own makes this a good trick to use. So 3 divided by 3 becomes 1. 1x squared is easier to deal with. Minus 18 divided by 3. And finally, 4/3. Fractions are not really an issue at A level. We don't mind them. In fact, they're generally quite good to deal with. The rest of the question, well, if we complete the square, we could then move these number terms to the other side. And because completing the square makes x only appear once, you can work backwards. Notice the plus or minus here because we're solving a quadratic equation. And you can get an answer such as this. This now brings you then to 2C and 2D. I believe parts of this also visit using the quadratic. And the challenge here actually is to do what we just did, to manipulate into getting x squared and to derive this, because completing the square and the quadratic formula are really very much the same thing. Pause the video and have a go, and I will reveal the proof for you just for a bit of fun. So you will not be expected to answer this in the exam, but as you can see, dividing through such that you only get x squared when you are equal to 0 is a common trick. This is a bit harder to follow, but this is half of what was here from before. This is actually completing the square. There is some tricks with fractions here as well at the end, but an interesting insight that completing the square will lead to the quadratic formula. Okay, in the next section, we will look at linking this with functions.